Welcome to our review on infrared radiation 2. So the first thing we need to remember is what we've already covered in the previous video, that every object absorbs and emits infrared radiation. If the object is at a constant temperature, then the rate at which infrared radiation is absorbed is the same as the rate at which it's emitted. If we see the situation where an object absorbs infrared radiation at a faster rate than it's emitting the infrared radiation, then the temperature of it will increase. And if we see it emit infrared radiation at a faster rate than it absorbs it, then it will decrease in temperature. One thing that we do find is that the surface is going to affect the amount of radiation that's emitted. So a light shiny surface will emit less radiation than a dark matte surface. And you may have done an experiment or seen a demonstration using the little cans at the bottom there to prove this. One of the key things that's affected by infrared radiation is our planet Earth. And the temperature of Earth is actually dependent on quite a number of different factors. So these factors include the rate that light and infrared from the sun are reflected back into space, that they're absorbed by Earth's atmosphere, that they're absorbed by Earth's surface, and then on the other side that they're emitted from the Earth's surface and that they're emitted from Earth's atmosphere back into space. So I know that we kind of take this atmosphere thing for granted here on Earth, but it's actually vital to our existence. Because if we didn't have an atmosphere, then we'd actually be experiencing temperatures like those on the moon. So during the daytime, temperatures potentially of up to 100 degrees Celsius, and then at night it would plummet down to minus 173 degrees Celsius. So pretty extreme. So the atmosphere is vital to the existence of life on Earth. The key part of the atmosphere that's going to actually absorb this infrared radiation is the greenhouse gases. Now, the greenhouse gases actually absorb longer wavelength infrared from Earth, and they prevent it from escaping back into space. So there are 3 greenhouse gases that we need to know, both for physics and conveniently for your chemistry course as well, which are carbon dioxide, methane, and water vapour. So what we actually see happening here then is that as the sun emits the infrared radiation, it travels through space and then travels through our atmosphere and warms the surface of the Earth. The Earth then emits longer wavelength infrared radiation, and the greenhouse gas molecules absorb that infrared radiation before re-emitting it back to the Earth's surface, and that then leads to the planet warming up. Hopefully at the end of this video you can describe what surface makes the best emitter, you can explain why the atmosphere is important and how the greenhouse gases actually play a role in keeping the planet warm.